Today we are going to discuss about integration. Integration is nothing but reverse process of derivative. Last year we are studied about derivative. Do you are remembering? Derivative of x is 1. Derivative of x square is 2x. Derivative of x cube is 3x square. Derivative of log x is 1 by x. Derivative of x power n is n into x power 1. Remembering? Okay. Today we are what about integration? Definition. Integration. What is the use of integration? On completion of this period, we would be able to understand indefinite integral, constant of integration, standard integrals. So integrals are two types, that is indefinite integrals and definite. Definite integrals is second unit. This is the indefinite integral is first unit. We are discussing only first indefinite integrals. Integration. Define velocity and give the equation. Velocity is the rate of change of displacement, that is v equal to ds by dt. Velocity is the rate of change of displacement, that is v equal to ds by dt. The velocity of an object at any instant is given. Can we determine the position of the object at any instant? A velocity, once again I repeating, if velocity of an object at any instant is given, can we determine the position of the object at any instant? Yes, we can determine the position of the object by a procedure called integration. What procedure? We can determine the position of the object by a procedure is called integration. Definition of an integration. That is, integration is the inverse process of differentiation. In integration is the inverse process of differentiation. Suppose dy by dx equal to f of x is given. This is first year. Dy by dx is derivative. First year, second sem first year. Dy by dx equal to f of x. Suppose dy by dx f of x is given. Now we have to express y in terms of x. Y in terms of x. Then we call y as integral of f of x. Integral of f of x. And this is represented symbolically as integration dy equal to integration f of x dx. So take out the denominator dx as right side. Apply both sides and integration. That is integration dy equal to integration f of x dx. Derivative integration is inverse process. So therefore d and integration cancel. This equal to y equal to integration f of x dx. Okay, this type of s symbol is called integration. Okay, the integration deals with the problem of finding a function whenever its derivative is given. Once again, integration deals with the problem of finding a function whenever its derivative is given. Here, integration is the initial letter of the word summa or sum, sign single of integration. This symbol is sum of or summa. The above statement is read as integral of f of x with respect to x or integral f of x dx. So above statement is read as integral of f of x, integral of f of x with respect to x, integral of f of x with respect to x, either integral of f of x dx. This can be read as from the Latin word integralis or whole. F of x is called integrand. X is called the variable of integration. Here, integral f of x in integral f of x is called the integrand. Integrand. X is called the variable of integration. Here x is called variable of integration, oral f of x is integrand. So in the integration f of x dx, here f of x is called integrand and x is called the variable of integration. Hence, f of x dx is called the indefinite integral of f of x with respect to x. First, in this unit, we discussing indefinite integral. Next unit, we define definite integral. Here, hence, f of x dx, f of x dx is called the indefinite integral of f of x with respect to x. f of x dx is called the indefinite integral of f of x with respect to x. That is, evaluating integration f of x dx used to find capital F of x, a function of x, whose derivative with respect to x shall be the integrand of f of x. Once again, that is evaluating integration f of x dx is to find capital F of x. Evaluating f of x equal to the capital F of x of a function f, whose derivative with respect to x shall be in the integrand of, that is f of x. That is f dash of x equal to f of x. Derivative, take out the left side derivative right side, that equal to integration f of x dx equal to capital F of x. Alternatively, we can define integration as the limit of a sum of certain series. Alternatively, integration definition. Alternatively, we can define integration as the limit of a sum of certain series. Integration is the limit of sum of certain series. Many useful application of calculus depend on this method. Many useful application of calculus depend on this method. This method is very useful in calculation problems. But it is not a convenient as the former is evaluating the integral of a function. It is not as convenient. So not convenient of functions. It is a integral of function. Thus, finding the integral of a function is called integration, but it is not a convenient as a former in evaluating the integral of a function. Thus, finding the integral of a function is called integration. Finding the integral of a function is called integration. Constant integration. We know that d by dx equal to x square. D by dx of x square equal to 2x. First year formula. X square derivative of x square is 2x. Derivative of x square plus 5 is, so here x square derivative 2x and 5 is 5 derivative is 0. 2x plus 0 is to 2x. And derivative of d by dx of x square minus 3 by 4 is x square derivative 2x. 3 by 4 is a constant. Constant derivative is 0. That is x is 2x minus 0 is just 2x. That is integration of 2x dx has many values. Therefore, if we if we take d by dx as right side, that it will become a integration. Integration of 2x equal to answer x square. And also in second example, take out the d by dx as right side, it will become a integration. Integration of 2x answer is x square plus 5. And the third example, take out the left side d by dx as right side. It will become right side as integration. Integration 2x dx answer is x square minus 3 by 4. That's why integration 2x dx has many values. Integration 2x dx has three different values. That is 2x. So that is x square and x square plus 5 and x square minus 3 by 4. So the derivative of a function when it exists is a unique function. The integral of a function is not so. So the derivative of a function is unique, but integration is not unique. So integration of 2x gives so many values. Integration of 2x gives x square. Integration of 2x x square plus 5. Integration of 2x x square minus 3 by 4 also. So it is not unique. The integral of function is not so. This is expressed by this. This is expressed by writing Integration of 2x dx is x square plus c. Here c means here c gives the values. In first example is c value is 0. In second example c value is 5. In third example c value is minus 4, 3 by 4. This is expressed by writing integration 2x dx equal to x square plus c, where c is a constant called a constant of integration. Called a c is called as constant of integration. In general, if there is a function f such that d by dx of capital A fx is equal to f of x for every x belongs to I interval, then for any arbitrary number c belongs to A, d by dx of f of x plus c also f of x belongs to R, since derivative of a constant function is 0, then we say that f of x plus c is an antiderivative or integral of f of x. Symbolically, we write integration f of x equal to capital F of x plus c. So, in this means, see second point. So dy dx of f of x equal to f of x plus c also f of x. And in first point, d by dx of f of x equal to capital F of x is also f of x. Derivative of f of x is f of x, and also derivative of capital F of x plus c equal to also f. Take out left side derivative, that is d by dx. Take out into right side. Take out d by dx into right side, that changes as integration. So in first point, integration terms, f of x equal to integration capital F of x equal to integration f of x plus c. In second point, take out d by dx as right side, that is f of x plus c equal to integration f of x dx. So integration f of x dx gives the two values. So that's way we take always integration f of x dx is equal to capital F of x plus c. So see second point, d by dx f of x plus c, capital F of x plus c equal to f of x, comma f of x belongs to R. Since derivative of a constant function is 0, then we say that f of x, capital F of x plus c is an antiderivative or an integral antiderivative of f of x. Symbolically, we write integration f of x dx equal to f of x dx equal to f of x plus c, capital F of x plus c. Since c is unknown and arbitrary, since c is an arbitrary or unknown and arbitrary. Integration. C will change. In previous example, C is one in place as C is 0, in second place C is 5, in third place C is minus 3 by 4. So therefore, since C is unknown and arbitrary constant, like our integration f of x is called an indefinite integral of f with respect to x. Integration f of x dx is called an indefinite integral of f of x with respect to x. Indefinite integral of f of x with respect to x. Standard integral. Standard integral first. So integration x power n dx equal to x power n plus 1 by n plus 1 plus c. So see second one, see right side in second. Derivative of log x is 1 by x. So take out the derivative in left side, that is integration. Integration 1 by x dx equal to log x. So derivative answer is integration question. Integration question is derivative answer. And that first year answers are here integration questions. 1 by x is the log x answer. Though this is 1 by x is the integration. Next, third one is it is also easy one. Integration of e power x dx equal to e power x plus c. Always put plus c on all equations because c will give different answer. So put it as c, it's safe. Fourth one, integration a power x dx equal to, sorry, integration a power x dx equal to a power x by log a plus c. And fifth one is a power x is just typical integration of a power x dx equal to a power x by log a plus c. And fifth one, integration of sin x dx, that equal to integration of sin x is minus cos x dx. In first year, derivative of cos x is minus sin x. So put it symbol as right side. Integration of sin x dx is cos x plus c. In first year derivative, derivative of sin x is cos x. Sixth formula. Just see reverse, right to left. Derivative of sin x is cos x. Take out derivative on left side, that is integration of cos x dx equal to sin x plus c. So integration is a reverse process of derivative. Remembering is very easy because we are well, well known about derivatives and formulas and derivatives. So next, integration of secant square x. Actually, derivative of tan x is secant square x, but integration of secant square x is tan x plus simple. And also derivative of cot x is cosec square x, cosec square minus cosec square x. That means integration of cosec square x is minus cot x plus z, obviously. Okay, next, derivative of sec x is sec x plus tan x. That means integration of sec x tan x is equal to sec x plus c. And in the formula, derivative of cosec x is cosec x plus cosec x into cot x. But integration of cosec x cot x dx equal to minus cosec x plus c. Inverse functions. Derivative of sin inverse x is 1 by under root of 1 minus x. Here, integration of 1 by under root of 1 minus x square dx equal to sin inverse x plus c. Next, derivative of cos inverse x is minus 1 by 1 by root of 1 minus. Here, simply integration of minus 1 by under root of 1 minus x square dx equal to cos inverse x plus c. So, this is also easy. In derivative of tan inverse x equal to 1 by 1 plus x square. So similarly, integration of 1 by 1 plus x square dx equal to tan inverse x plus c, or we can integration of dx by 1 plus x square equal to tan inverse x plus c. And 14th one, integration minus dx by 1 plus x square equal to cot inverse x plus c. And 15th, integration 1 by x into under root of 1 minus x square dx equal to sec inverse x plus c. 16th one, minus integration 1 by x into under root of 1 minus x square dx equal to cosec inverse x plus c. 17th one, in hyperbolic function, integration of sin hx dx equal to cos hx plus c. There is no changes, minus symbol. Integration of cos hx equal to sin hx plus c. There is no change in the signs. Next, integration of say sec h is sec h square x dx equal to tan hx plus c, and cosec h square x dx equal to minus cot hx plus c. Integration of sec hx into tan hx dx equal to minus sec hx plus c. Integration of cosec hx cot hx dx equal to minus cosec hx plus c. Still minus place to remember. Properties of indefinite integrals. D by dx of integration f of x dx equal to f of x, because d by dx and integration is opposite or reverse. Integration is reverse process of derivative. Derivative d by dx and integration cancel. Therefore, f of x dx equal to just f of x. Integration f dash of x dx equal to derivative. F dash means derivative. Derivative integration cancel. That equal to f of x plus c. Integration f of x plus g of x dx equal to, so split in two parts, f of x dx plus or minus integration g of x dx. There is no change. Integration constant k into f of x dx equal to k into f of x dx. Fifth one. Integration k1 f of x plus or minus k2 g of x dx is equal to constant k1 into integration f of x dx plus constant k2 into integration g of x dx. So this is common way. So solve one example. So evaluate integration ax square plus bx plus c by x cube into dx. x cube into dx. Integration ax square plus bx plus c by x cube into dx. Divide ax square by x cube. Divide all elements by x cube. That is integration ax square by x cube plus bx by x cube plus c by x cube into dx. The record here small a is a constant term, take out outside. Integration 1 by ax square, numerator x square, denominator x cube. So square cancel, that is remaining is 1 by x dx plus b into. Here take out b as a constant and take out outside. B into integration 1 by numerator x and denominator x cube. X cancel, remaining is 1 by x square dx. So sorry, dx is in the numerator part, not a denominator part. Plus c into integration 1 by x cube dx. So apply formulas. Integration for second formula. 1 by x is log x into integration 1 by x is log x dx plus b into 1 by x square. 1 by x square. Take out 1 by x square is x power minus 2. X power minus 2. B into x power minus 2. X power in formula x power n plus 1 by n plus 1 integration x power n formula n plus x power n plus 1 n plus 1 that equal to x power minus 2 plus 1 by minus 2 plus 1 plus c into take out 1 by x3, so x3 as numerator x power minus 3 x power n formula x power n plus 1 that means x power minus 3 plus 1 by minus 3 plus 1 plus c is equal to a into log x plus b into x power minus 2 plus 1 is minus 1 by minus 1 that equal to x power minus 1 is 1 by x. A log x minus b by x plus c into minus 3 plus 1 is minus 2 that is minus 2 x power minus 2 that equals c by 2x square plus c1 plus c1. Next question, evaluate x plus 1 whole power 4 by x square dx. Numerator is a plus b whole square or whole power 4 formula. Divided into two parts, that is x plus 1 whole square into x plus 1 whole square. Write the a plus b whole square formula. So a square x square plus b square 1 square a square plus b square plus 2x into 1 to x, and as second one is x square plus 2x plus 1 by x square into dx. Multiply numerator terms x square into x square x power 4 x square into 2x is 2x cube, 2x into x square is 2x cube, that is 4x cube, x square into 1 no, x square into 1 no, totally 6x square, x square into 1 no, x square into 1 no, 2x square, 2x into 2x, 4x square, 4x plus 4x square into 2x square is 6x square. Next to 2x into 1 no, 2x into 1 no, 2x plus 4x, 1 into 1 is 1, 4x plus 1 by x square dx. Divide with the numerator term by every term by x square. Integration x power 4 by x square is just x square. 4x cube by x square is just 4x. 6x by x square by x square is 6. 4x by x square is just 4 by x. 1 by x square is 1 by x square dx. Is equal to that equal to integration of x square. Integration of x square is x power n is x power n plus 1 by n plus 1 that equal to x square integration is x cube by 3 plus 4 into x integration is x square by 2 plus 6 into integration of 1x is x that is 6x plus 4 into 1 by x is log x plus 1 by x square is 1 by x square x power minus 2 plus 1 by minus 2 plus 1 plus 8 So answer is x cube by 3 plus 2 2s of 4, that is 2x square plus 6x plus 4 into log x minus 1 by x plus c. Next, third question. Evaluate tan square x dx. Tan square x, there is no formula in tan square x and tan x also. So tan square x can be written as secant square x minus 1. So that is 1 plus formula 1 plus tan square x equal to secant square x. So therefore, tan square x equals secant square x minus 1. Apply integral. Integration of secant square x dx minus integration of dx. Secant square x integration formula is tan x. Dx integration is, that is 1 dx is x plus c. Summary. In this class, we have learned the formula of some standard integral and integration f of x dx equal to f of x plus c. Integral symbol c is integral constant, f of x is integrand. Integral symbol c is integral constant, f of x is integrand. Next, we have determined the integrals using the properties of indefinite integral. So last we determined some problem. Determine the integrals using the properties of indefinite integrals. Quiz. Integration 3 power x dx. 3 power x integration is a power x. You like the a equal to 3 a power x formula. A power x integration formula. A power x by integration of a power x dx equal to a power x by log a. That is here log a equal to 3. A power x by log a plus c. So B is the second answer. Second B is the answer of this question. Next, in integration, evaluate integration sin x dx to sin x is called, in integration sin x dx. Sin x is called what is, in integration f of x dx. F of x is called integrand. In integration sin x dx, sin x is called integrand. Here sin x b is the correct answer. 3 3 dx. Here 3 is the constant term. 3 into dx, 3 into 1 dx. 1 dx is x. 3 into integration 1 dx. 1 dx integration x. 1 x in dx integration x plus c. 3 into x plus c. C is the correct answer. Next assignment. Evaluate integration 3 by under root of 1, 3 by under root of 1 minus x square plus e power x plus 8 dx. Yeah, this is the easy question. E power x integration we are well known, and 8 is a constant. 3 by under root of 1 minus x square is a simple question. Take out 3 as common. 1 by under root of 1 minus x square answer is, I know. Uh, this type of formula we have. Second one is 1 by 1 minus sin x dx. Is this difficult? Is it difficult? Simply, uh, what we do, rationalize it. Simply rationalize this. Multiply and divide with 1 plus sin x, 1 plus sin x. In denominator, 1 plus 1 minus sin x, 1 plus sin x is replace b minus a square minus b square. Denominator will give cos square x, 1 minus sin x by cos square x. It is also easy question. So next, so by heart all these formulas and do X assignment. I will tell you different types of integral formulas in next class. Okay, thank you.